Hi, today we're going to start on page 489. Today we're going to talk about multiplying matrices. So we're back to our two girls with their cutting boards. And you can see we have Monique and Chandra, style 1, 2, 3, and the other one, the styles go down and the type of wood goes across. So the first matrix, remember when you name this, you go down and then across. That's how you give it a name, whether you're giving it dimensions or with the words. So this first matrix, we'll call this one the first matrix. This is a person by style matrix. We're going to multiply that by, if we go down, a style by wood. And what happens is the styles overlap. So the output of one and the input of the other are the same. So they basically are gone. And we end up with a person by wood matrix. So we're going to have the type of wood that each person needs. So that's what happens when we multiply. Multiplying, be prepared to do this without a calculator. So we'll go through it a few times. I'm going to write it all out. It takes a second to kind of get track of what's going on. You can see that they have the first position, upper left-hand corner. So this is, you can see we're going to end up with a 2 by 3 matrix. So you want to make sure we keep everything in the same position as the parts. So you can see they went 5 times 4, then 3 times 0, and 4 times 8. So you go across and down. And I'll do it several more times. So to show you what we're going to do here, we're going to go across and down the maple, because we're going to be in the maple column. So it's going to be 5 times 3 plus, now we're here, 3 times 5 plus that 4 times the bottom one, the 5. So now we're on the cherry. We're right here. So again, we go across and down. So this is going to be, and we start here always, 5, now we're here, times 2, plus 3 times 4, plus 4 times 0. All right, so now officially we are done with using Monique's numbers. So now we have to do this whole thing again with Chandra. And so we're going to be here and walnut. So we go down, we go across the 442 and down 408. So it's 4 times 4 plus 4 times 0 plus 2 times 8. So we're done with walnut. Now we're on maple. We're back to here again. 4 times 3 plus 4 times 5 plus 2 times 5. They were nice enough to have done that last one. So now basically just go through and do the arithmetic. So this is 30 plus 20, so that's 50. And we just go through 10, 12, 0, so 22. 8, 0, 16. This is going to be 32 in this position. And the center mid is 12, 20, and 10, so that's 42. And that's how you multiply matrices together. Now we'll go through that again here in a second. But some details on positioning. All right, so I'm going to rewrite this matrix on here so we can have it. So I know you can probably flip it back and forth, but the matrix we just had, which was, the person by wood matrix, or D times S, or matrix DS, we had Monique and Chandra, and then we had the walnut, the maple, and the cherry going across. So these were the answers we got. We're going to talk about the positioning of these elements in this matrix. A matrix, as you know, is just a rectangular array of numbers. Each number has been given a position by its column and row. So remember, rows go down, columns go across. And so they're asking you, I'm looking at part C right here, sorry. Which entry in matrix D times S, the one we have, shows the number of maple strips that Monique needed to purchase? We're going to do this with a notation. So this is, of course, the 50. We want to go down first. So we're going to call little e for element. And we went down 1 and over 2. So this is a subscript of 12. Down 1 over 2. So it's down 1 over 2. Let's take a look at F. Which entry in matrix DS shows the number of walnut strips that Chandra needs to purchase? Write it in notation. So here we're Chandra and walnuts. We're right here. So we went down 2 over 1. You have to count that first position. So that was down 2 to the right 1. Now I would also like to try to squeeze in here, just to try it one more time to see if you got it. Down here, part C. What information is given by the entry in the first row in the third matrix column? So this would be E sub 13. So look at it. Down 1 over 3, down 1 over 3. So the number is 22. But I want to know what the matrix, what the information is. This is the cherry wood that Monique would need. So just see, hopefully you got it, needs, sorry. All right, let's talk some more about this multiplication and how you know if two matrices can be multiplied together. That's the big thing. Not all matrices is possible to multiply together. It's like not all matrices are possible to add or subtract either. So if we go through this, I'm going to write this a little bit. Matrix R is a 3 by 2. Matrix S is a 2 by 4. And matrix T is a 4 by 3. And so if we take a look at R times S, matrix RS. So we're talking about a 3 by 2 times a 2 by 3. And so the way this works is the number of columns in the first one has to equal the number of rows in the second one. Otherwise, it's not possible. So what you're looking at are these two numbers closest together if you write their names like that. And so what happens is these two are gone, and our result is a 3 by 3. So just because you're starting with two that are maybe similar in size, maybe even the exact size depending, it does not mean that they will end up being the size. Like the 3 by 3 is not even a size that R or S were in the beginning. So the answer can be completely different. So let's take a look at ST. If we were to multiply ST, that's a 2 by 4 matrix times a 4 by 3 matrix. First of all, it is possible because the 4s match, so these are out, and the result, your answer, would be a 2 by 3 matrix. But if we think about R times T, so R is a 3 by 2, and T is a 4 by 3. This is not possible. These numbers do not match. So if you are told to multiply this together, you would just say not possible. The dimensions don't work. So again, the number of columns in the first one has to equal the number of rows in the second one. So we're going to try another one. It says find each product, state if it's not possible. We're going to do this without the calculator. This is a nice small one. So just to see if you got it. And so I'm going to, remember we have to go down. We have to go across this one and down the second one. So I'm going to put it over here. So we're going to have 4 times 3 plus -1 times 5, because we got to go down. Then in the upper right-hand corner, we're still on that going across. So 4 times, now we're going to go down the second one, 4 times -2 plus -1 times 1. So now we're going to be here. But back up to going down this first one. So now we are -2 times 3 plus 6 times 5. I don't know why I have to say that at the end like that, sorry. And so then the last one would be across this one and down that far right-hand one. So this one is -2 times -2 plus 6 times 1. Put that in matrix, and then of course you would just simply do the arithmetic. So this is going to be 12 minus 5, so this is a 7. -8 minus 1, so this is a -9. -6 plus 30, so this is 24. And 4 plus 6, so this right hand is a 10. Now for part B, remember you go down then across. So this is a 2 by 3 times another 2 by 3. This one is not possible. And that's what you would say if you were asked to multiply things that are not possible. So let's go back to addition real quick. Let's just talk about order. It says properties hold true for real numbers. Some of these properties will also hold true for matrices. You have the properties list there on the left-hand side. We're talking about commutative, associative, your identities, and then of course commutative, associative, and identities for both addition and subtraction. So they're asking you to test that commutative property. Does the order matter? Does A plus B equal B plus A? So we are adding here. So if we add A plus B, and it's possible to add these matrices together because the dimensions match. So when the dimensions are the same, you can add or subtract. So this one will be 9, and then 8, 7, and 2. This is B plus A. Oops, sorry, that is A plus B. I went left to right. So let's do B plus A. Reverse a little bit, 5 plus 4, oops, sorry, 6 plus 2, 2 plus 5, and 4 plus -2. So you can see that addition is commutative. Two M's. So addition is commutative. The order doesn't matter. Now, for A, B, and BA, on the calculator, there is a shortcut, the alpha zoom. Now you don't have to use that shortcut, and some of you won't have it. If you don't have it, no problem. There's a nice matrix key. You go second matrix. It's right below math. You have to go over to edit. The first thing it's going to ask you is for the dimensions of your matrix. So you put that in. You'll see that the matrix starts to form on the calculator screen, so you'll know if you do it wrong. Then one by one, you have to enter the dimensions. 4, enter. 2, enter. 5. You have to hit enter after each one. Be sure to hit enter for the last one as well, otherwise it will not get inserted. So then we go back and go second matrix. Now go down to matrix B and enter in that matrix. Then when you have it all entered, you clear that screen, completely get out of it. Make sure you go back to the home screen and it's nothing on there, no numbers, hit clear. Go back to matrix. And with the names, you make sure it says matrix A, and you don't have to hit the time sign, you can if you want to, and then matrix B. And then just hit enter. So you make the arithmetic done on with the names. So A times B is this matrix, 24, 32, 21, 22. Now we're going to do matrix BA. Now you don't have to re-enter them, just on the name screen. So again, clear that, and then go back to second matrix and do B times A using your names. And then this matrix is 50, 28. This is a -2, this is a -4. So you can see here that multiplication is not commutative. So the order matters for multiplication. Order does not matter for addition. Or it does obviously matter for subtraction because it always does. So multiplication is not commutative. So you really have to pay attention to the order, not just is it possible with the dimensions, but also make sure that you are putting them in the calculator correctly and make sure that you're doing all that stuff. All right, so let's take a look at 11A. I want us to do BC. And if you look at matrix C, it just has 1s and 0s in it. Same thing with matrix E. So matrix BC, when we multiply B times all these 1s and 0s, we get 5, 6, 2, 4. We get itself again. If you do the same thing with DE, you'll see that we get the same matrix again. We get D again. So we would get 5, 0, negative 2, 4, 1, 3, 2, 2, 1. So because the identity of the original matrix did not change, this is called the identity matrix. And it says for part C, for a square matrix, describe what the multiplicative identity matrix I appears to be. Obviously, it's ones and zeros only. And the position of the zeros and the ones are both very important. If we take a look at this 3 by 3 matrix right here, the ones will be in diagonal from the upper left-hand corner to the lower right-hand corner, with the zeros filling in all the rest of the spaces. So this is your multiplicative identity matrix, and we're going to need this later when using the matrices to solve problems, solving linear equations. So that's why it's important. We're going to use this again later. Now you have an assignment for tomorrow on page 493. Please do 15 through 23, odd, just the odd numbers.